Hello geometry students and welcome to lesson 6.2. In this lesson we're going to look at kites and trapezoids and theorems for both. So in example 1 we're going to look at the diagonals of a kite. So first of all you should recall that a kite is a quadrilateral that has two pairs of congruent sides, but opposite sides are not congruent. Okay, so let's see, the diagonal, so point B is equidistant from the endpoints of AC, as is D, so they lie on the perpendicular bisector of AC. The diagonals of a kite are perpendicular to each other, so exactly one diagonal bisects the other. So these are some important facts to keep in mind when you're working on problems related to kites. Okay, that you have right angles, which means you have right triangles. Okay, and again, you have that one diagonal that bisects the kite, and just the one. Okay, in example 1, let's see, we're asked what is the measure of angle AXB? Okay, so again, these diagonals are perpendicular to each other, so we know that the measures of the angles at point X are 90 degrees. If AX is equal to 3.8, what is AC? Again, we know that BD is the perpendicular bisector of AC, so if AX is equal to 3.8, AC is equal to 3.8 times 2, which gives us 6 carry the 1, 7.6. So theorem 6.3 is about the diagonals of a kite, and it states that the diagonals of a kite are perpendicular. You're going to be learning lots of different facts about different quadrilaterals. So at some point there's going to be a lot to remember, but we'll organize it all and try to keep it straight. Okay, in example 2, we're going to use the diagonals of the kite to answer some questions about the angles. So pause the video, go through and try these problems. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So angle 1, again, is 90 degrees. Angle 2 is the complement of 35 degrees. So we have a right triangle. And angle 3 is congruent to this angle, QPT, because we have an isosceles triangle. Right? This is an isosceles triangle as well. Okay, keep that in mind. Okay, for this example, the measure of angle 1, that is the complement of 32. The measure of angle 2 is equal to 32 because, again, this diagonal XZ is a bisector. Right? It's dividing that kite into two congruent triangles. Example 3, explore parts of an isosceles trapezoid. So we have a trapezoid-shaped roof, and in order for the roof to be symmetric, the overlapping triangles DAB and ADC must be congruent. So we're asked, will the roof be symmetric? So I'm going to give you a little hint to get started here. Your first step, you want to show that ABE is congruent to triangle DCF. After you've done that, then you can show that triangle DAB is congruent to triangle DAC. So pause the video, put some thought into this, okay, write some things down, and then come back when you're done. Okay, for step 1, let's see, we know that BE is equal to CF, because they are both altitudes. The roof is an isosceles trapezoid since DC is congruent to AB. So trapezoids in general, trapezoid is a quadrilateral that has one pair of congruent sides. That's its definition. Or, I'm sorry, one pair of parallel sides and only one. Okay, that's what sets it apart from parallelograms. In parallelograms, both pairs of opposite sides are parallel. For a trapezoid, you only have one pair of parallels. When the non-parallel sides are congruent, we call it an isosceles trapezoid. So now we know that triangle ABE is congruent to triangle DCF. They are right triangles and they're congruent by HL. So in step 2, by CP-CTC, we now know that angle DAB is congruent to angle ADC, and by the reflexive property, we know AD is congruent to DA. So now we know that the triangles are congruent by SAS. So since the overlapping triangles are congruent, the roof is symmetric. Okay, given isosceles trapezoid PQRS, what are the measures of these angles? So again, keep in mind that you have the one pair of parallels. Let's see, go through and try these examples. Read through the theorems, right? We have in an isosceles triangle, each pair of base angles is congruent. So we have congruent angles here, and we have congruent angles here as well. Again, this is only when it's isosceles. The diagonals of an isosceles trapezoid are congruent. Okay, so like I said, there's lots of different facts that you're going to learn over the course of topic 6. It's a lot to remember, a lot to keep organized. So try these examples. When you're done, come back and we'll compare solutions. Okay, so the measures of angle PQ and S. Hopefully you got 45, 135, and 45, because remember we have congruent angle pairs. So this angle is the same. Q is the same as R, and P is congruent to S. Because of the fact we have parallels, do you remember the name of this angle pair? Consecutive interiors, right, which are supplementary. Okay, given ST is parallel to RU, what is the measure of TUR? So hopefully you got 133 degrees, because again, we have consecutive interiors, so they're going to be supplementary. Oh, I'm sorry, this is an exterior angle. So the interior plus the exterior has to add up to 180, so they're supplementary as well. Okay, pause the video and try these two examples. And come back when you're done and we'll compare solutions. Okay, let's see how you did here. We have an isosceles trapezoid up here at the top. We're told angle 1 is 138 degrees. So angle 2 is its supplement. Okay, here we're asked for the length of each cross support. Because of the fact that this is an isosceles trapezoid, right, we've got congruent. These are called legs. We can set those expressions each equal to each other. C is equal to 4. We can plug in that value and get the length of 19 feet for each cross support. Okay, 2 more problems. Pause the video, try these 2, and then come back when you're done. Okay. For this one, hopefully you got A equaling 14. And for this example, you're given BD and AC. So again, we're setting them equal to each other, solving for the variable, and plugging in to get the length. So theorem 6.6 is the trapezoid midsegment theorem. So in a trapezoid, the segment containing the midpoints, x and y are midpoints, of the two legs is parallel to the bases. So all three of these segments are parallel. And its length is half the sum of the lengths of the bases. So you could think of it as the average. It's the average of the two parallel sides. So in this example, we have a handbag, and she stitches decorative trim along the top, the middle, and bottom on both sides of the bag. So how much trim does she need for 3 handbags? So go ahead and give this a try. Pause the video and come back when you're done. Okay, let's see how you did here. So let x represent the length of the mid-segment. So x is half the sum of 6 plus 9. So then we can add up the lengths, multiply by 2 for both sides, and multiply by 3 for the 3 handbags. So Paxton needs a total of 135 inches of trim. Okay, go ahead and try these 2 examples. Pause the video when you're done. Come back and we'll compare. Okay, so in this one, we're asked what is the length of KL? So JM is 4/5 the length of XY. Okay, so that would be 20. And that's going to make KL a length of 30 meters. For the dog park, the length of the new fence, we can use our new formula, 1/2 of 70 plus 120, and we get that the length of the new fence is 95 feet. So for our concept summary, remember that a kite is a quadrilateral with 2 pairs of adjacent sides that are congruent and no pairs of opposite sides that are congruent. Exactly one diagonal is the perpendicular bisector of the other. For the trapezoid, we have exactly 1 pair of parallel sides. The length of the midsegment is the average of the lengths of the 2 bases. A trapezoid with congruent legs is isosceles. So we have not only congruent legs, but we also have congruent base angles and congruent diagonals. So that concludes lesson 6.2. I hope you enjoyed it, and I will see you in class. Have a good day.